Right, so this is a video tutorial to support the computer practical for the SED assignment. What I'm going to do is just run through the analysis and what we're expecting from you. So first of all, it's worth going to Blackboard, to the Sediments exercise folder, and have a look at the SED Facies Properties Sheet 2016, which is what we're looking for you to hand in for this assignment. And if you have a look at this first of all, you can see that there's 4 questions. The first question is based around the analysis from this computer practical. So calculating mean size, sorting and skewness for all the samples that you performed the sedimentary facies analysis on in the field. So that will include the samples that you collected with Yakko on your SED day, but it will also include the samples that you collected as a whole class at the beach near Gint's Point on the day, on PAL 2 day. Okay, so you should have data spanning both of those days. So question 2, you present your sedimentary facies analysis, the descriptions of the morphological elements, and then question 3 and 4 are asking you to interpret the data that you're presenting. So what I want to concentrate on in this video is how you calculate the mean size, sorting and skewness for your samples. So the first thing to do is to download the student sieving data, which I've done here. And what you'll see is, if we look at the tabs below, the first tab here, all data, just has a list of all the morphological elements sampled. Tab 2 has the calculations. For you this will be blank, but I'll get to that in a moment. So these are the calculations for graphic mean, calculating the sorting and skewness, and this is what you're going to need to calculate those variables. And then at the bottom, each of these tabs represents one of the morphological elements which is listed under all data. So if we take the channel, for example, what you need to do first of all is calculate the cumulative percentage coarser than value for each of these 5 values, only going to 5.4, and you can do that using this equation here. What you'll then need to do is take this data and plot it using sigma plot. So you need to use this program or file here, and I don't have sigma plot on this computer, so what I'm going to do is just show you via the lecture what we want you to do is take your cumulative percentage coarser than values and plot them in sigma plot. So you'll go to this, your sigma plot file has 2 tabs, the data and the graph. So you need to populate the column 2 in the data in order to create this figure. Note that for the samples that have not been sieved, such as mudflat and creek, these sort of muddier samples, they've actually been processed through the Malvern particle sizer. Notes, supplementary notes for this are actually in the Excel file, so just read any supplementary notes about each sample. and what you'll need to do is just make sure that you plot all of the extended phi values in column 1 for those samples. What you should then be able to do is read off your figure for each of the percentiles, so the 5th percentile, the 16th percentile, the 50th percentile, 84th percentile and the 95th. This is an example here where you put the cursor over to find the 50th percentile, and what you want to do is extract that x value for the 50th percentile, and you'll need to do that for all of them. Once you've done that, you should have a value for each of your samples. So I've just got 3 examples here, 3 morphological elements here. You will have more, but for the purpose of this tutorial I'll just use these 3, and what you have is a value for each of the percentiles for each morphological element. So then the next step, once you've got these values, is to use these values to calculate these, to solve these 3 equations. And I want you to do that in MATLAB. So one way you can do that is to simply copy and paste. If we open a new variable, and you can just copy and paste these values into a new variable like this. You'll need to rename it something sensible like d-values. And you'll also need to save it. So if you save d-values, that will save all the variables in your workspace, which just happens to be 1, and it'll save it to wherever you are, you know, whatever directory you're at. So if I clear all, I can load d-values. They'll appear in my workspace. Okay, that's one way to do it. You can also take your data and put it in a new Excel file. Save it as whichever directory you're working in. I call these d-values. And what I'm looking for you to do here is to create your own script. So you'll need to go to New Script and File, save that script. Something like Sed assignment. And using the example from the lecture that I gave at the beginning of the computer practical, I'm looking for you to structure and comment the script appropriately. Okay, and so things like giving it a title, explaining what you're doing, and you know, for really it's to show me that you understand what your script is actually calculating it on each line. But what we can do here is load the data, which if you saved it as a mat file here using the first method, then you would write load d values, and that would be loading your data. Or if you've saved your data into an Excel file like d values, you can say d values, or whatever you want to call it, and then you can use a function called xls read, and then the name of your file, values.xlx. And then if I run that, see that d values appears in my workspace. Really important to start with a clean workspace. We'll do that. Okay, now what you need to do is take these 3 equations and translate them into MATLAB. And one of the ways that you can do this is to actually take this table that you have and extract each of your d values. And so to do that, so if I wanted to name d5, that would be equal to d values, all rows, column 1. So what that is doing is extracting this column here. If we run that one line by highlighting it and pressing F9, we'll see that D5 has now been extracted. So you can do that for each one. And then you can get to calculating mean size. And if we check the equations, that's equal to D16 plus D50 plus D84 divided by 3. Okay, so what you can then do is simply write that out as a formula in MATLAB, which will be very similar, but you'll have to think about where you need to put brackets. And you may find that when you are multiplying or dividing using matrices, so more than one row, more than one column, that before you either times something or divide something, you will need to provide a dot beforehand. And what that does is tells MATLAB that you want these calculations or these functions performed row by row or cell by cell. So what you need to do is go ahead and continue with this through to skewness, which, as you can see from the equations here, gets slightly more complicated, so you'll need to be careful about where you put your brackets, where you put these full stops before dividing by matrix or column. And one of the ways that you can then double check that your work is right is go to the lecture and use these skewness and sorting classification tables to see whether your numbers, your values, fall within these values, and also if they do, what, say for example we're talking about sorting, what degree of sorting does it give? If it says that it's well sorted, does that match the notes that you made in the field? So you've got sort of two levels of quality control there, and with the size you can refer to the Wentworth scale, see the classification for the size range that you've come out with, and again see if that matches or makes sense with the notes that you've made in the field. Remember, when it comes to writing up this data here, I'm interested in the values, but I'm also really interested in the classification. Okay, because a value for sorting itself doesn't tell me enough. What I need to know is it what does that actually equate to? Is it well sorted? Is it very well sorted, etc. So use those classification tables to do that. Okay, good luck.